I had learned the what, but not the why. My motivation: too many unanswered questions. As problems get more and more difficult, and as you try to understand nature in more and more complicated situations, the more you can guess at, feel, and understand without actually calculating, the much better off you are. Once you get the idea that the problems are not mathematical problems but physical problems, it helps a lot. Richard Feynman. At the heart of many fields, physics, chemistry, engineering, lays thermodynamics. As a chemical engineering student, I was continually frustrated in my attempts to deeply understand this subject. Such concepts as flowing heat, free energy, maximum work, and multiple versions of the second law didn't make sense to me. Attempts by the teacher to present a cause-effect chain of logic rarely, if ever, got to the foundational bedrock. We were taught the concepts and associated equations we needed to know, but rarely the physical meaning and historical origins behind them. Admittedly, it was difficult for the teachers to drill down so deeply in the classroom, where the amount of material to teach overwhelmed the time available. But even after I graduated and sought to educate myself, I faced significant challenges in finding the relevant material. It was at this point that I became motivated to find the answers, put them in a book, and so share them with others. I succeeded in my professional career, 2 Fortune 500 companies and MIT's Department of Chemical Engineering, because I knew how to solve problems using the skills I acquired during my formal education, including those associated with thermodynamics. But I could have achieved even more had I had a greater intuitive understanding, a la Feynman, of the physical nature of the problems involved, for such an understanding would have provided me with more confidence, more strength, and more creativity in using these skills to solve them. My technical background, combined with my researching and writing this book, has placed me at the interface between 3 worlds: practitioner, academician, and historian. I offer an original perspective on thermodynamics from this interface. I have spent my career working with other practitioners and students, and am aware that many of them, including me at the time, had challenges in deeply understanding the concepts central to thermodynamics. In fact, I vividly recall one conversation in which a fellow PhD student told me, "I tried reading Gibbs and couldn't get past the 3rd page." To conquer the challenge of Gibbs, and many other challenges, what is entropy? I searched through much relevant literature to answer my repeated why questions, stopping short of going too deep into material irrelevant to my objectives, such as quantum physics. I then extracted the answers I sought and combined them with my own practitioner insights and perspectives into a coherent, seamless whole. This book targets the student who is asking the same questions I asked, whether the student is in the classroom, the laboratory, the office, or the home reclining chair, and whether the student is a practitioner, an academician, or a historian. In addition to offering a different way of approaching the subject, one that enables greater confidence and creativity in approaching and ultimately solving the thermodynamic problems, this book also offers the student inspiration by historical example. When students read about Galileo rolling up his sleeves to finally conduct an experiment to quantify free fall, they may be inspired to roll up their own sleeves and go into the laboratory or the chemical plant to conduct their own experiments, gather their own data, and so challenge their own hypotheses. General approach. This book is structured in 4 parts. The first describes the physics behind the origins of the elements, starting with the Big Bang. The second, the atom and its features. The third, energy and the conservation laws. And lastly, the fourth, entropy and the laws of thermodynamics. I included the first 2 parts since I felt it relevant to include the science on the origin and behaviors of atoms in a book on thermodynamics. I structure each part to lay the foundational building blocks of both the what and the historical and theoretical why